Okay, so in this problem we are required to determine the shear force and bending moment at points C and point D. The given structure rests on two supports A and B. A is a roller support and B is a fixed support, which means that at A we will have a vertical reaction, let's call it AY, and at B we will have two reactions, a horizontal reaction, let's call it BX, and a vertical reaction, let's call it BY. Now, in order to calculate the value of AY, we will take a moment about B. Now, since the structure is in static equilibrium, the net moment about B must be 0. In all our problems, we will be taking counterclockwise moment as positive and clockwise moments as negative. So, we have 500 times 8 minus 300 times 8 minus AY times 14 equal to 0, which gives us AY is equal to 114.29 pounds. Let us now look at the section AC. Now at C, we will have a horizontal normal reaction called NC. We will have a shear force VC. At A, we have the vertical reaction from A called AY, and we have a load of 500 pounds. Now, applying static equilibrium conditions, we have total force in x direction equal to 0. So NC is 0. Now total force in y direction is equal to 0, which means we have AY plus VC minus 500 equal to 0. So VC is equal to 500 minus 114.29, which is equal to 385.71, which can be approximated to 386 pounds. We also have a moment about C, let's call it MC, directed in the counterclockwise direction. Now, in order to calculate the value of MC, we take the moment about. Alright, so we have MC plus 500 times 4 minus 114.29 times 10 equal to 0. Therefore, MC is equal to minus 857 pound feet. So these are the two answers that we're looking for. Moment about C and shear force about C.